Hi, welcome to FunEdPy videos. This is DC here. In this video series, I'll be showing you how to use OMNIKEY 5022 reader writer. Now, this is a product from HID Global. Now, if you want more information about this product, you can go to this the manufacturer product page. So this is the reader writer. So if you want to download any documents, especially the developer's guide, you can do it from here. So first of all, I would like to mention that this 5022 series is not the latest reader. There are so many readers that came after this. However, there's one particular reason why I'm interested in this reader writer. So this reader writer will be of very useful for software developers who like to integrate their software with the NFC or RFID technology, as well as the students of technology as well. Now, the reason why I like this reader writer is it supports various standards. You can read and write to a type A cards, you can read and write to type B cards, and you can also read and write to ISO 15693 tags, as well as you can also read and write to a card based on I-class. So I have not used I-class cards, so I would not like to comment anything more about that. However, making a video on I-class card is in the list of things to do for me. So you're going to very soon see a video on I-class as well. If you have seen the readers from other manufacturers, say for example, I have worked a lot with reader writers from a company called ACS, like ACS, ACR122U or 1252. Most of these reader writers supports only the protocol of type EA or standards of type A and B. So if you have to use any RFID tag based on ISO 15693, then you cannot use the reader writers from ACS, unless ACS have got a new product that also works with ISO 15693 standards. Some of the other reader writers that you can buy from the HID are the 5422. I do have this reader writer with me. The 5421, I have played with this, and these two readers I have not used myself. So, but one thing what I know is the 5321 and 5421 are more or less similar. Probably 5421 has got a little bit more features than 5321. So the 5023, so looks like this is a successor of 5022, something like that. But again, I've seen the documentation of 5023. This is slightly different from 5022 as well. So you have to know or you have to understand the feature of all these reader writers before you decide to buy any of this. So this is a general introduction about how most reader writer works. So if you open any reader writer, you will see an RFID reader writer chip. This is the chip that actually communicates with RFID tags. So you'll also come across a firmware. This is written by the manufacturer of the device. So this will be based on some kind of a single chip processor, and this firmware is what interfaces between the host, that's our PC or the application, or the chip itself. So this is like this is the intermediary between the host and the RFID tags. Now the firmware, again, it can do so many things. It all depends on the manufacturer and what they want the reader writer to do. But most often the firmware will do the pooling of the RFID tags. Pooling means looking for any new tags entering the RFID field, and as soon as it finds one, it is going to inform the PC or the software that there is a car ready in the field, and the firmware will receive the APDU from the host, and this is the commands that are used to communicate between the host and the device, and it sends the the chip specific commands to the reader, and whatever data received from the tag, it sends it back to the PC, and again sends it back to the microcontroller, and finally it might send back to the host as well. So the capability of the device, it depends on what the firmware can do. So the reason why I stress these things here is, it is quite possible that you have got a brand new or a tag which has got more features, but you might come across a situation where you cannot use those features. Is because the firmware doesn't let you do that. So you have to know what to do in such situations. Now most reader writers, in order to overcome this restriction, the most reader writers supports a concept called the transparent channel. Now this is a concept whereby the software can send the commands which are not understood by the firmware, or the software can send the commands directly to the card. So if the reader writer does not support the transparent channel, then you cannot use the features of the tags. So you have to look for a different reader writers, or probably you have to wait for the manufacturer to provide the firmware upgrade. So this transparent channel is, as I mentioned here, it's a way to bypass the firmware and send the commands directly to the card. So I made a small sketch to explain you how most reader writer device works. So I thought the diagram will be helpful to you. Now this is what you see inside the device. You'll have a microcontroller. This could be based on the single chip computer from STM, or it could be any kind of a microcontroller. You got the RFID chip, and these two things can be completely different chips, or they can be integrated into a single chip. And you have the antenna, and this is the host or your PC, or it's our software. Now first what the software does is, what the host does, it sends a APDU to the firmware. The firmware decodes the APDU. APDU is a command structure. It's a very high level commands, and the APDUs works with most readers and most RFID tags. So this is like a device independent command, and this is driven out by the standard, which is ISO 7814, I suppose. So what the firmware does here is, it decodes the APDU, and it will eventually maps these high level commands to the card or the chip specific commands. Now those commands are sent to the RFID chip, which will in turn which will send it to the card, and whatever data you get from the card is first received by the RFID chip, sends it back to the microcontroller here. Again, this might do some processing and sends back the response in a different APDU. So the APDUs are of two types. One is the request APDU, where the direction of command is from the PC to here, and the response APDU, where the direction of the data flow is from the microcontroller to the PC. So as I mentioned before about the transparent channel, so some document also call this as a transparent mode. So in this mode, the host or the PC software sends a APDU command structure, and the firmware knows this APDU structure is for the transparent mode. It will take, in this case it will take this path. Now the firmware is not going to map it to any card specific commands. Whatever is there, it's going to send it to the reader writer, which will again pass this to the tag, and the response from here is passed back to the firmware and back to the host. So what you have to keep in mind is, if you want to use every features of the card, you must look for the reader writer that allows you to do that. So what you're going to learn in this video series is using 5022 you're going to see how to read and write to various tags. The number of tags that are listed here is limited as and when the new tags are added to the software. So you're going to see a video on that. So at present the 5022 supports at present the software which I'm going to show you supports MIFARE Ultralite, Ultralite C, NTAC 213 and MIFARE Classic. And the most important thing here is you have to understand the transparent mode and how to use the mode. And to be honest, all these big words like transparent mode and transparent session, they are pretty simple. They're very easy concept if you start reading this developer's guide. Now, like always, you have to have a copy of the developer's guide. I showed you where to get that from. And the most important thing is, it's very interesting, it's very helpful for the developers and the students, is get a copy of this sample codes from OMNIKEY website. If you go to the knowledge base, or probably in the download section, you can download the sample codes, and this is going to be really helpful if you want to know how to program 5022. Now this is some of the points I've highlighted here, what you should look for when you buy a new reader writer. So first thing is, obviously you have to look for how many standards the reader writer supports. We know that 5022 supports type A, type B and IS 15693, plus it also supports the NFC standard as well, NFC forum data as well. Now you should also look at the developer's guide and see all the operations that you can do with the firmware. Now the main reason or the main purpose of the firmware is to make programming easier. Now again, the device capacity or capability depends on what the firmware can do, and also look for this as well. So does the firmware allows you to send commands directly to the card? The best place to look for this is, you can email the manufacturer, and also check if the firmware is upgradable, and also check how often and where to get it from. Check if the reader writer comes with the secure access module. This will be useful when you start using cryptography. And some devices like 5022 comes with an additional EEPROM. This is a nice thing to have, where you can keep all the data. Some of the keys, we can keep them safe as well, and also see how much documentation we can get. And most reader writers, they do come with sample code where they show how to use this device with Java, C#. This is very helpful. And some devices, they come with the SDK. Look for whether it's a free or whether you might have to pay a few pounds. And if you get it for free, it's fantastic. Most of the work is done by the SDK as well. So with this background, so I'm going to show you how to use 5022. Before I show you the software using OMNIKEY 5022, so I thought I will show you the transparent mode or transparent session, comparing the one in 5022 and the one in 5321 or 5421. Now this is a section you're supposed to understand very well. So if you look at here, using this transparent session command, you can change the protocol, you can change the speed, change the field, you can turn off and on the RF field. And there is a command called transreceive. This is the command you're going to use to send the raw command to the card and get the response back. And so the transparent session will be started using the enter transparent session, and you can exit with exit transparent session. So one thing you have to keep in mind here is, as soon as you enter the transparent session, the device will stop auto polling, will stop polling for the cards. Now you have to be careful. Sometimes if you close the software, the device will no more recognize the new tags, so you have to disconnect from USB and reconnect. Now this is the one that are used in 5321 or 5421 reader writer, and here if you see that the command structure itself is different compared to the one with the with 5022. Now if you already written the program for 5321, it's very obvious that it will not work without changing the code with the 5022. Now here in case of 5421 5321, so you don't get that much options where you can change the frequency or a bit or a CRC stuff, so that also you have to keep in mind. So this is the software we used to train students on OMNIKEY reader writer. So you can see I have connected my brand new OMNIKEY 5022. This is a very small size compared to the readers like 5421. Now when I hit show readers, the software shows all the PCC complaint readers connected. So this is the one, and this time I'm going to show you the simplest tag, the MIFARE Ultralite. And see, I don't want to make this video as yet another tutorial on MIFARE Ultralite, because I've already made so many tutorials on MIFARE Ultralite using the different reader writers. The screen is exactly the same. So here what I'm going to show is just the commands that you have to know when you start programming 5022. So I'm going to activate. If you look at the commands tab, you'll know all the commands that are exchanged between the software and the reader writer. I'm going to hit read entire tag. So the good thing about these Ultralite is all these read and write are done using the standard PCSC commands. Like to read 4 pages at a time, we use the read binary command. So there are 16 pages altogether. I have read from page 0 and the last page is starting from page 12. This reads 4 consecutive pages. So in order to write, you just select a page there and go to this screen. I'm going to type 01 01. So here also the write is done using a standard update binary command. This is a PCC complaint command. This is the command structure. So there is nothing something complicated here. Everything is pretty straightforward. Even to write the OTP or the logs, we still use the same the update binary command. So far we have not used the transparent mode at all. So next I'm going to show you the MIFARE, the Ultralite C. So I'm going to choose the MIFARE Ultralite C screen. If you activate, now if you see what's going on here, again these are the standard stuff we do. This is the command to get the UID of the tag. Before that you connect using the PCSC library, and this is the ATR. Most of the time when you get these type of ATR, you copy this and go to a website called ATR string, and that will tell you what type of card is that. Now I'm going to now hit read tag. Now here Ultralite C has got altogether 48 pages starting from number 0. In order to read all these pages, so in fact you cannot read the page number 44 to 47. Again, I've got some fantastic videos on MIFARE Ultralite C. I would advise you to look at that. If you look at the commands that are used, so all the commands are the standard PCSC read binary command. So that shows you can read all these pages starting from page 0 to page 48 with the simple read binary command. Now you know that MIFARE Ultralite C has got a password protection. So in order to, you can protect the card with the password, and it has got a 3 days authentication feature. So in order to use this authentication, you have to use the transparent mode now. So I'm going to authenticate. This is the default key. If I hit this button, it says authentication OK. If you look at the command series here, so if you ignore this bit, now look at the command series. The actual authentication command, if you look into the MIFARE Ultralite C documentation, now it is done in 2 steps. Okay, this is the first step, authentication, and the second step, authentication. So in order to send these, the card specific command, you have to first start a transparent session and use the card specific commands, then exit the transparent session. Now this is the flow you have to follow. So you have to first enter the transparent session, run all the card specific command, and do not forget to call exit transparent session. So these commands are very well explained in the documentation of 5022. And this one place where you have to use that. There are other places as well. For example, Ultralite C has got a counter. Now in order to increment the counter, there is no counter increment command in Ultralite C. Ultralite C tag is purely based on the read and write concept. There is no counter specific commands like you see in other tags. Now I'm going to increment the counter by 10. Right. Now here, if you look at the command, this is in a, again, what I have noticed is the standard update binary command does not work from page number 40 onwards, and this is probably due to the firmware sitting in this reader writer. So maybe the firmware knows this is an Ultralite C, and the data array ends from 0 to 39. Anything the write operation from 40 onwards, so if you try to do that, you will get an error. Now the question is, we just don't know why it behaves. Now that is how the device behaves. Probably now we just have to stick with that. So in order to write for page number 40, I have to use the tag specific command. Now this command, what you see here, called A2 29 followed by the 4 bytes, it's exactly what the MIFARE Ultralite documentation says. If you look for write operation, now this is the card specific command called write, and the documentation says this looks complex, but it's from the programmer's point of view, we just have to know the value of the bytes you have to send, so we don't have to worry about this diagram. Now the command to write a page is the command A2 and give the page address followed by the data, so we don't have to worry about the CRC because that's automatically computed by the 5022 firmware. So if you go back to the software, it's a A2. I'm writing to page number 29, that's the hex of 41, and the value I have to send all the 4 bytes, so only the first byte is written. So this, when you send this command, now you have to keep this in mind. Somehow the response you get is not the right one. So we would expect the response as 9000, and this should be also all 00s. However, this is a kind of execution error type of command. I'm not sure why we get this. Probably it's better we check with the technical support of OMNIKEY guys. So you just have to ignore, keep in mind, so don't look for 9000. So I'm 100% sure the write is successful, because soon after the write operation I'm reading back the value of the counter, which is and what you read is, what you get is the modified value, that's 30. So I'm going to try again, add 10 more, you got 51. So here, this is the 51, this is the hex equivalent of 51. So what we have seen just now is, so any write operation after this user data section, you have to use the transmit mode. So likewise, if you want to modify the dynamic locking, so I'm going to set a lock on page 1627, right? So here also I have seen you can't use the normal update binary. So if you really want to know that, please try to write using update binary, and you should get the error message will be something like a 6A82 saying that the address is not valid. So I think that's all you have to know when you start using this 5022. So everything, if I have to I can show you now how to write to auth 0, auth 1. So what you end up seeing is a series of enter transpensation, the write operation, and exit transpensation. So I'm going to take one more example, but this time using the MeFair Ultralite EV1 tag. So I'm going to choose MeFair Ultralite EV1. See, we have tested the software with the NTAG 213 TT and 210U. So in there also you'll end up seeing how the transpensation is used. So we have done something different in MeFair Ultralite EV1. Now, so the main purpose of Ultralite EV1 is because it has got the signature, it has got the password, it has got so many counters, and most of the time you will end up using these new features. Otherwise you can just go back to the Ultralite. Now for that reason, so as soon as this tag is activated, we are starting the transpensation. So what we have done is the transpensation is activated when the tag is activated first, and all these operations are done. You don't have to keep entering transpensation, execute and close. We don't have to do that. This is a kind of a optimization you can do. So, and also to learn that you can have the session open and you can close it when the screen is closed. Now here you can see that we have used the command called get version. So this command is explained in Ultralite EV1, and this command is what tells you the type of the card. And also if you hit here, again I've made some good videos on MeFair Ultralite EV1, explain every bit and reading the documentation as well. I would advise you to see that. So here, if you did not do this enter transition session here, you will end up having every command a sandwich between enter transition, exit transition. So here in this case you don't have to. I'm going to read. Now we notice something here. Say for example, the firmware it's probably now knows that it is a MeFair Ultralite EV1 and does not let you use a ordinary read binary command from page 16 onwards, because in Ultralite EV1 the user data ends at page 15. Everything after that is either a configuration or the password or counter. So if you try to read using an ordinary read binary command, the page 16, 17, 18, 19, you will get a error 6A82. So in order to read it, you have to use the card specific command, that is reading 30, and here also. So because the transpensation is already open, you don't see any more open and exit here. So likewise I'm going to authenticate. So we know the default password is all FFs. Now authenticate. So if you look at the authentication command, it's just using the transreceive. This is the command that's available in the transpensation. So here we send the password command and you get back. The result is so clean here. The first 2 bytes are 00. So if you see a read counter, so the first 2 bytes 00 indicates a success, followed by followed by the data. Now again, the 2 bytes are explained very well in the documentation. And look, if you look at here, the last 2 bytes are always 9000, so that's also a good sign of success. So likewise, if you want to change the counter, now I have got a count. There are 3 counters here, so I'm going to add 100 to counter. I'm going to clear. So right, if you look at the command here, now this MIFARE Ultralite EV1 has got a special command for incrementing the counter. So that's A500, and this is the one. So it's not a simple write to a page. There is a command to do the incrementing. So likewise, in order to read, what the software does, it increments the counter, then reads back. And here also you can see that every time somehow you use this, you get this 0608F6F00. If you go back to documentation and look for the meaning of 6F00, it says execution error. Somehow I just cannot now understand why we get this. It's better we check with the technical support. So I have seen this working, so you can ignore this. So just to make this transparent mode concept stronger, I've connected this time the OMNIKEY 5321, and in the beginning of the video I showed you 5321 has got a different bytes for entering the session, transparent session. So I'm going to show you, for example, this Ultralite C, here. So I'm going to activate and read. Now if you look at here, even here also you can read all the pages right from 0 to 39. It's fine. And when it comes to authenticate, here the authentication, you can see it's still, we have to start the session, run the authentication commands and close the session. And here the command structure is different, and that's the only thing you have to be aware here. Also the result is pretty clean. You get 0 zeros here and 9000. If you want to write, I'm going to write to the counter, increase the counter by 10. So here also, if you look at here, so this result is better than 5022. Here the right page 41 returns a clean 9000. If you remember, in case of 5022 we had 0608 6F and 00. So this is a positive right. So just before I finish this session, take this Ultralite EV1, so select that, activate. So here also the session is started at the beginning itself, and all these card specific commands use a different transparent mode command set, and everything after this is the same. It's just a different format of this command. If you see the ECC, this is the originality signature. You can see that this is the structure of the transparent transistor command, and everything works without any problem here. Authenticate. So here also authenticates. Now what the software does is, as soon as this is the screen is closed, the software automatically uses that close exit. Otherwise, if you don't close it, next time when you come here and if you try to activate a tag, you will never get any response, because when the transparent session is active, the device stops doing the auto pulling. So that's you have to keep in mind. Okay, I think this video gave you enough background on the transparent session, and probably you're comfortable playing with the 5022. Thank you.